Hello, statistics student. This video is for chapter 4.3, binomial distribution. In the last video, we talked about how we can use statistics to find probability of a random variable that can be modeled by binomial. And we talk about the 4 requirement, which is what has to have fixed number of trial. It must be independent. Each trial must be independent. And also each trial has exactly 2 outcomes, success and failure, and you are counting success. So X basically is the count of success in the end trial, and the probability of success in every single trial is P. So we say we can use statistics to calculate a probability, and I didn't write down the X value that we input. So if I want n equal to 12, p equal to 0.25, but we want exactly 5 success, so we say x should equal to 5, and then we use p of x, right? P of x will give us p is exactly 5. And if I want 5 or more success, we would also enter x equal to 5, but we would use not x, but x or greater, right? Because, in the statistics calculator, they give us 3 columns whenever we enter some number. So if I enter 5 and I hit evaluate, they will it will give us 3 column p of x. That means p is 5, probability of 5. Then p of 5 or more will be upon this, and 5 or greater. Okay, so they give us 3 probability. So it depends on what you want. So if you do want 5 or fewer, you would enter x equal to 5 in the calculator, but you read off x or fewer. It's just exactly called x or fewer. That means 5 or fewer. It would give us the probability of 5 or fewer. Now, so the last two is a little tricky. I didn't complete it in the last example. We say n is 12, p is 0.24, but we want probability of more than 5. Now, more than 5 does not work if you enter x equal to 5, because more than 5 means what? 6, 7, up to 12, right? 6, 7, up to 12. So that is more than, it will be 6 or more. So instead of entering 5, you should enter 6. And you will say x or more, greater. Great. So you read off that one by entering 6 to find more than 5. So we did that last time. We entered 6 because that would corresponds to 6 or greater 0.0453. 453. What about probability of x is less than 5? Less than 5 means you only have 4 success, 3 success, up to 0 success, right? So that means I want to do x is equal to 4 because you start off with 4. You don't do 0, right? And then you do, probability of what? 4 or fewer, right? X or fewer. You use the X or fewer column. So you don't use 5, you don't use 6 for less than 5 because you have to interpret what is less than 5 means. I can see 4 success or 3 success like that. So that would equal to what? We haven't done it, so we would change this to 4. Then do evaluate. We want less than 5, so it will be 4 or fewer, 0.0x623. On 0x623. Okay, so I want you to pay attention to this one. More than 5. Probability of your success out of 12 times is more than 5. It's only 4.5%. It's less than 5%. So it is really rare to see more than 5 success, right? More than 5 success. So 6 or greater than 6 all add together is very low chance of happening. So you can say that 6 is actually already unlikely and not be able to happen. Okay, so when we discuss discrete probability, discrete random variable, we always talks about mean, variance, and standard deviation. So if it is a binomial, Fortunately, we don't have to enter the tables. Remember the P, X, and P of X that we have to enter into a LibreText expected value calculator to find these value. But because of the nature of binomial distribution, the probability, you go to the factorial things, right? N factorial, X factorial, N minus X factorial. Is really because of the nature of Q of N minus X of the probability. When we do X and times P of X, after a gigantic simplification, it turns out that the mean is N times P, which makes sense. Just think about it. If you are doing 12 observation, every time you have only 24.24 chance of happening, what is the average? The average will be 12 times 0.24. So N and then P. P is the probability of success in one trial. And what is variance? Variance is MPQ. So remember Q is 1 minus P. Okay. So you just multiply this and that would be sigma. And what is the standard deviation? The standard deviation is the square root of these, so it's square root of MPQ. So the power of mathematics, after you do a lot of simplification, it actually can show this. Okay, we skip all this simplification, but if you are interested knowing why it is like this, because earlier when we do discrete random variable, we have to use a calculator to calculate. But if it is a binomial, so that's why binomial, if x can be modeled by binomial, it's very easy to find mean, variance, standard deviation. So but then this range rule of thumb is still the same. The value of x that is not significant is between mu minus 2 sigma and mu plus 2 sigma. So to find this binomial distribution parameter, of course, you can just do by hand because you have the formula here. NP is the mean or expected value. Standard deviation is square root of NPQ or NP 1 minus P. But when you do the statistics probability calculator, you will see that they actually have calculated for you. No matter what x is, you can have x equal to 5. Okay, they don't care. So this stays the same because NP would result in mean N times P, square root of NP 1 minus P, square root, and square root of and then NPQ. Okay, so these are already calculated in the bottom of the statistics analysis, probability distribution, and binomial distribution. So it's already there. So, but you can also calculate yourself. Okay, so after that, then we'll see how we can use the calculator to do some applications. Now, all these applications are modeled by binomial distribution. You can think about, when you look at this, you think carefully about whether yourself, how come this can be modeled by binomial distribution also? In a college, 35% of all students are full-time students. So that means out of everyone, there's 35% chance of one student at full time, right? In last time, we say this is the relative frequency. Relative frequency is probability. If you select one student, there's 35% chance that that person is a full time. But I'm selecting 11, so this is sampling, right? If I sample 11 students, can I use the number of full-time students out of 11 be modeled by binomial distribution? Let's check. A, check if it is, do I have fixed number of trial? Fixed N? Yes. Equal to 11, so this is S. Are they independent? When I select students, uh, does one being a full-time affect the next one being a full-time? No, they're all independent selection. And I can assume it because 11 students is less than 5% of the whole population. So 11 students is really low unless you only have like a class of 40 students, right? So it is about college. So 5% rule apply. Even though you're sampling without replacement, you can still treat it as independent. Number 3, do we have two outcome? Yes, full time is what you are counting, but not full time, part time or whatever is the failure, right? Only 2 outcome. And then the fourth one is is probability of getting a full-time student always 0.25? Yes, it is the same because even if we pick one, the number of students that is full-time would not change, right? It's a big population. B, what is the probability that there are 4 full-time students out of 11? Because this can be modeled by binomial, we say it is binomial n is 11 and then 0.35, right? So I want n, so we have n and p is fixed, and I want that exactly 4. Exactly 4 would be, use the calculator, I would change this to 11, 0.35, and exactly 4. Evaluate. So because I'm doing exactly, so I use p of 4, 0.2428, round it after. Use x equal to 4, use p of x, so that would equal to 0.2, what? 0.2428, right? X equal to 4. But use this. You don't look at the fewer or greater. C. What is the probability that there are less than 5 full-time students in the 11 students? Not the whole college, but less than 5. Less than 5 means what? 5, 4. So I can just use 4, right? I don't use 5. And 5, 4, 5 or is it 5 or fewer or just less than 5? Just less than 5 would be 4 or fewer, so it would be 0.6683. So use x equal to 4, use p of x or fewer, 0.6683. What is the probability there are more than 3? More than 3 means what? There are 4 or 5, right? 4 or 5 or 6. So I use x equal to 4 again. I do not use x equal to 3 and then use x or greater because that would be 4 or 5. So 0.5744 equal to 0.5744. So that's how you do it. So remember not to use 3, but use 4 in this case for more than, and for less than, use 4. Okay. Example 2. A book manager estimates that 9.5% of all customers coming in the store will buy a book. So this probably is from a relative frequency kind of experiment. And then if in a day there's 24 customers that visit the store on a certain business hour, so can X equal to number of customer out of 24 who buy a book be modeled by binomial distribution? So we have to check the 4 things. First, do I have fixed number of trials? Yes, 24 is fixed. They're just counting out of this 24. And are they all independent? Supposedly those customers comes in individually, so they should be, right? So assume individual customers. They are not come together. They don't come together. So I think in the airport, well, I don't know. So sometimes it's valid, sometimes it's not valid. So it depends on the cases. Number 3, so it depends on actually the shop. So we assume that they are independent customers. They don't affect, like one customer might buy doesn't affect the other customer will buy a book or a magazine. So it's a bookstore. Number 3 is, am I counting buy or not buy, right? So that's very clear cut. 2 outcome. And do we know the probability of someone buy a book? So we have the probability, right? P equal to 0.095. 9.5% is 0.095. So we can say we can be modeled by binomial, and sometimes we write as binomial, and P is binomial 24 and then 0.095. Now in this case it's 3 decimal places. You cannot use the online stat book. You have to use StatDis. So I'm using StatDis to illustrate this. Find the probability that exactly 3 customers. So for exactly 3 customers, I would do, what was it, 24.095. Exactly what? Exactly only 3 customer buy. Okay, evaluate. And we would just look at P of X, 0.2133. Right? So just use that number because we want exactly that number. 0.2133. C, find the probability that at least 5 customers will buy. At least 5 means This would be 5, 5 would be 5, 6, 7, right? So you do 5x or greater.